Semi-supervised learning, combining labeled and unlabeled data. Title: Semi-supervised learning, combining labeled and unlabeled data. Introduction. In the world of machine learning, the availability of labeled data is often a limiting factor in building effective models. Labeled data helps in training models to recognize patterns accurately, but manually labeling data is time-consuming and costly. To overcome this challenge, researchers have developed a technique called semi-supervised learning, which combines both labeled and unlabeled data to improve predictive performance. This article aims to provide an overview of semi-supervised learning, its advantages, and its applications across various domains. Understanding semi-supervised learning. Semi-supervised learning is a machine learning methodology that enables models to learn from a combination of labeled and unlabeled data. Traditional supervised learning algorithms rely solely on labeled examples, where each data point is associated with a corresponding target value. However, in many real-world scenarios, acquiring labeled data can be expensive or impractical. This is where semi-supervised learning steps in, leveraging the abundant pool of unlabeled data to augment the limited labeled data. The main intuition behind semi-supervised learning is that the unlabeled data contains some underlying structure or patterns that the model can exploit to generalize better. By incorporating this unlabeled data during the training process, the model can gain a more comprehensive understanding of the underlying data distribution, leading to improved predictions. Combining labeled and unlabeled data. The combination of labeled and unlabeled data can be achieved through various techniques within semi-supervised learning. Two common approaches are: 1. Self-training. In self-training, a model is initially trained on the limited labeled data. After this initial training, the model is then used to predict labels for the unlabeled data. The labeled instances from the unlabeled data, along with their predictions, are then added to the labeled data. This process is iteratively repeated, continuously refining the model's predictions and incorporating new labeled data until convergence. 2. Co-training. Co-training involves training multiple classifiers separately on different subsets of the features present in the data. Each classifier is initialized with a small set of labeled data. After each training iteration, the classifiers exchange their predictions on the unlabeled instances. The instances on which both classifiers agree are considered confident predictions and are added to the labeled data. This process is repeated till convergence. Benefits of semi-supervised learning. Using semi-supervised learning offers several advantages, including: 1. Reduced reliance on labeled data. Semi-supervised learning reduces the dependence on costly labeled data by utilizing the abundant unlabeled data. This makes it more feasible to build accurate models on a larger scale. 2. Improved predictive performance. By incorporating the unlabeled data, semi-supervised learning helps models capture more comprehensive representations of the underlying data distribution. This often leads to improved predictive performance compared to purely supervised learning models. Applications of semi-supervised learning. Semi-supervised learning has found applications across various domains, including: 1. Text and document classification. Semi-supervised learning has been successfully applied to tasks such as sentiment analysis, spam detection, and topic modeling. By leveraging the vast amounts of unlabeled text data available, models can learn more accurate representations of natural language. 2. Image and video analysis. In computer vision, semi-supervised learning has proven useful for tasks such as object recognition, image segmentation, and video annotation. The ability to utilize unlabeled visual data enables models to better understand visual patterns when labeled data is limited. 3. Fraud detection. Semi-supervised learning can identify fraudulent behavior by modeling normal patterns from labeled data and identifying anomalies among the unlabeled data. This approach helps detect fraudulent activities without requiring a large set of labeled fraud instances. Semi-supervised learning has gained significant attention in the field of machine learning due to its ability to leverage both labeled and unlabeled data. While traditional supervised learning algorithms rely solely on labeled examples, semi-supervised learning takes advantage of the abundance of unlabeled data to improve the performance of models. One of the main advantages of semi-supervised learning is its potential to reduce reliance on labeled data. Acquiring labeled data can be time-consuming and expensive, especially in domains where expert labeling or annotation is required. A key aspect of semi-supervised learning is the assumption that the unlabeled data contains hidden patterns or structure that can be exploited by the model. By incorporating this unlabeled data into the training process, the model can generalize better and make more accurate predictions. There are several techniques for combining labeled and unlabeled data within semi-supervised learning. Two common approaches are self-training and co-training. In self-training, the model is initially trained on the limited labeled data and then used to predict labels for the unlabeled data. The instances with confident predictions are added to the labeled data, and the process is iteratively repeated until convergence. Co-training, on the other hand, involves training multiple classifiers on different subsets of features and exchanging predictions on the unlabeled instances. Semi-supervised learning has shown promise in various domains. In text and document classification, it has been successfully applied to sentiment analysis, spam detection, and topic modeling. By utilizing the vast amounts of unlabeled text data, models can learn more accurate representations of natural language. Similarly, in image and video analysis, semi-supervised learning has proven useful for tasks such as object recognition, image segmentation, and video annotation. The ability to exploit unlabeled visual data allows models to better understand visual patterns when labeled data is limited. Semi-supervised learning is an important technique in the field of machine learning that combines labeled and unlabeled data to improve model performance. Traditional supervised learning algorithms rely solely on labeled examples, which can be limited and costly to obtain. However, with semi-supervised learning, models can leverage the abundance of unlabeled data to enhance their predictive capabilities. The underlying concept behind semi-supervised learning is that the unlabeled data contains valuable information and patterns that can improve the model's understanding of the data distribution.